This video is about Chapter 16 and it gives tips on solving inequalities. The reason I've created this video is to help students develop the ability to visualize inequalities and to grow an intuition about them. So we're going to look at these 9 problems in this video. Before we do, I want to discuss them. The first problem is x is greater than or equal to -2 or x is less than or equal to 4. If you picture a number line, I'm going to blow this up for a minute. In fact, let's lift it up. If you picture a number line, x is greater than or equal -2 or x is less than or equal to 4. So we look at -2 and we look at 4. Now, if x is greater than or equal to, that means that everything to the right of -2, including -2, could be in the solution set for x is greater than or equal to -2. So let's go ahead and graph that. We're going to use a bracket. Let me do this in red, a bracket, and then our arrow goes off to the right. So anything inside of that red arrow will work, because if you select 3, for instance, if x is 3, 3 is greater than or equal to -2, so that works. The second inequality is x is less than or equal to 4. So we graph that inequality, and x is anything to the left of 4. When it says or, it means that the solution includes everything in the red as well as everything in the blue. So that means since the blue goes to -infinity and the red goes to infinity, then the solution set includes everything from -infinity to infinity. And so the solution set is going to be what's in the purple, which is everything from -infinity to infinity, because that's what's included in both groups. So I want you to look again at the problem. X is greater than or equal to -2 or x is less than or equal to 4. When you have an or and you have a greater than or equal to and a less than or equal to, then you're likely to end up with -infinity to infinity. So you have to visualize it. You can look at this problem and think, okay, x is going to be everything larger than this number and smaller than this number, and since those numbers overlap, then it's going to be -infinity to infinity. Now let's look at number 2, and I want you to visualize this. X is less than or equal to 6 and x is greater than or equal to 8. Well, if you draw a number line, then you know that x is going to be everything less than 6, less than or equal to 6, but x also has to be greater than or equal to 8. So the and means that both of these conditions must be true, whereas the or means either of these conditions can be true. So to see what conditions both of these are true, you look at your line and you see where the two graphs overlap. Since they do not overlap anywhere, then that means there are no solutions in here. And if you take any number, like 5 for instance, if x is 5, 5 is less than or equal to 6, but it is not greater than or equal to 8. If you take 7, 7 doesn't work in either case. So there is no number that will work for this case. Next, in number 3, we get to absolute value inequalities. And what you must remember for absolute values are that they represent distance. It doesn't matter what is in here. it's going to be some distance or it's going to be 0. Now, if it's a distance, like I said, it's either 0 or it's going to be a positive number. There's no such thing as a negative distance. You can't graph a negative distance. So what that technically means is if you look at a number line and you have 0, if you have x, the absolute value of x is equal to 5, we'll go with equal for now, then there's the absolute value of x and there's the absolute value of x. It means the distance from 0 is 5. Everywhere there is a distance of 5 from 0, that is the absolute value of x. So x represents distance. That means you have to think of two cases for every absolute value. You have to think of the case where the absolute value is equal to 5 or the absolute value is equal to negative 5. In a case like number 3, the absolute value is greater than 5, so you have to think the absolute value is either greater than 5 or it's less than negative 5. So again, you're looking at distances and you're saying that the distance from 0 has to be either less than negative 5 or greater than 5. So what you end up doing is creating two equations. 2x minus 3 is greater than 5 and 2x minus 3 is less than negative 5. And the reason you do that is because you're talking about distance from 0. So the distance from 0 is 5. X is either greater than that distance or less than that distance. And that's why you have the two cases of 5 and negative 5. Let's look at 4. 4 is where you have an absolute value is equal to 5, which is what we started with in 3 when we did this. So again, you're going to have two cases where x is equal to 5 or x is equal to negative 5. In this case, it would be 3x minus 7 is equal to 5, or 3x minus 7 equals negative 5. That shows you the distance from 0. 3x minus 7 is equal to 5, or 3x minus 7 is equal to negative 5. And what you have to do is solve for x. X will be different in this case, but the distance you're talking about is 3x minus 7. It's whatever's in the absolute value. So if you have greater than, an absolute value is greater than something, you're going to have a disjointed graph where you have stuff going to the left and stuff going to the right, but there's no solution in between. And the way you would write this, let's say if this were x is greater than 5, you would write the interval negative infinity to negative 5, which represents this part, and then you would say that's in union with 5 to infinity, which is this part. So if it's greater than, you expect a disjointed interval, because if you think about it, if it's equal to, you expect a specific distance with 2 points. If it's greater than, then those arrows are going to go further than that distance. And then the next case we're going to look at is if it's less than, and then if it would be less than that distance, then you'd be looking at this area here, which is a contained area. So we'll be looking at that one a little later on. When you have the case of an absolute value equaling an absolute value, if you have an equal sign, that means you're going to come up with x equals probably 2 points. Or if this equals 0, you're going to have x equals 1 point. But you won't have an interval, you'll just have x equals 2 points. And we'll solve this inequality later on, but your two cases are going to be 7x minus 1 equals 5x plus 3, or 7x minus 1 equals negative of that. Now let's look at some special cases. If you have an absolute value, and remember, anything inside the absolute value, this just represents a distance. And as we said earlier, a distance cannot be negative. So if you have somebody telling you this distance equals negative 8, well, you know it can't be equal to negative 8 because it's a distance. Cannot be negative. So you have no solution, or your solution is going to be the empty set. Similarly, if you have that a distance is less than a negative number, remember everything here represents distance in the absolute value. So this is a distance. It cannot be less than a negative number, and it cannot be equal to a negative number. So you also have the empty set. Okay, what about distance being greater than a negative number? Think about it. Can a distance be greater than a negative number? Well, yes, by definition, a distance is always greater than a negative number. So this is a distance, and it's always going to be greater than a negative number no matter what's inside of here. If 3x minus 12 works out to be negative 4, the absolute value of negative 4 is going to be positive 4, and positive 4 is greater than negative 8. So any value of x you choose, this will be a true statement. So anytime you see an absolute value on the left being greater than a negative number, it means all solutions are true, and your interval looks like that, and your graph looks like that. And in the last case, this is the last special case, you have an absolute value equaling 0. And we said earlier that an absolute value is either a positive distance or it's 0. If it's 0, that means there is only one value of x that can make this situation true. You only have one case to consider, and that's that case. So you solve for x, and you will get one value of x, which will be 1 point on a number line, and one number, which we'll solve for in a minute, in a solution set. Okay, so you can pause this video and go through these problems and solve them, and then check your answers on the preceding slides. In number 1, I know that x is greater than or equal to negative 2, or x is less than or equal to 4. Since it's an or, it means it can either be in the solution set of x is greater than or equal to negative 2. It can also be in the solution set of x is less than or equal to 4. So I know that if it's greater than or equal to negative 2, here's my number line, negative 2 and 4. And if it's greater than or equal to negative 2, it's going to graph like this. And if it's less than or equal to 4, it's going to graph like this. And the solution set will include everything in both of those solution sets. When you combine them, you get the graph negative infinity to infinity, which is written just like I said it, negative infinity to infinity. Okay, and then in another case, if you have x is less than or equal to 6 and x is greater than or equal to 8, it means both of those cases have to be true for your solution set. So if you think of everything in x is less than or equal to 6, wherever it overlaps with everything x is greater than or equal to 8, that's your solution set. But if you think of 6 and 8, and x is less than or equal to 6 goes this way, x is greater than or equal to 8 goes this way, you can see that they don't overlap. So your solution set is like that, and that's the answer. In number 3, you have an absolute value problem. 2x minus 3, the absolute value of that is greater than 5. So that means the distance that is shown in here, that distance is going to be greater than 5 units from 0. So it's going to be, here's 0, here's 5, and here's negative 5. This graph doesn't represent x, it represents whatever's in here. That amount is going to be either greater than 5 or less than negative 5. So you write two equations. I'm going to bring them down like this. You write 2x minus 3, that distance is greater than 5, or 2x minus 3 is less than, and you look over here on the graph, less than negative 5, and then you solve for both cases. Add negative 3 to both sides and divide by 2, and on the left you get x is greater than 4. For the second case, you add 3 to both sides and divide by 2, and you get x is less than negative 1. So you graph that, and you find that you're going to have a disjointed interval. So in x is greater than 4, you're going to write a parentheses and graph it like this, and x is less than negative 1, it's going to be like this. Now, when you're talking about distances, what you're saying is that the solution set that makes this amount greater than 5 is going to be every place where x is less than negative 1, and also every place that x is greater than 4. So choose something greater than 4, like 5. 2 times 5 is 10. 10 minus 3 is 7. The absolute value of 7 is 7, and 7 is greater than 5. So you know that this area works. Now choose like negative 2, something in this area. 2 times negative 2 is negative 4. Negative 4 minus 3 is negative 7. The absolute value of negative 7 is positive 7, and 7 is greater than 5, so that works also. But choose a value in here, like 0. 2 times 0 is 0. That leaves minus 3. The absolute value of minus 3 is 3, and 3 is not greater than 5, so this does not count in your solution set. So when we write the interval, we write what we see, and here we see that the solution set includes negative infinity to 1 with parentheses, and we put union for or union for includes both, and then we write 4 to infinity. So that's a disjointed interval, and that's what you get when you have a distance being greater than something. So for instance, here's the distance 5, and your amount is going to be greater than 5, so you're going to have a disjointed interval. Now let's look at an absolute value equaling 5. If you have an equal sign, that means your absolute value is going to be either 5 units from 0 or negative 5 units from 0. And it's going to be a point. It's not going to be an interval. So if your absolute value is equal to a non-zero number, then you will have two solutions. And you find these solutions by writing 3x minus 7 equals a distance of positive 5 from 0, or 3x minus 7 equals a distance of negative 5 from 0. So adding 7 to both sides and dividing by 3, on the left we get x equals 4. Adding 7 on both sides and dividing by 3 on the right, we get x equals 2/3. So you write this as a solution set, not an interval. You don't include brackets or parentheses. And then you draw a number line and you plot those points. You can say that's 2/3 and that's 2. And this is the case we talked about where you have a distance equal to another distance and you have to find the values of x that make that statement true. Again, since we have an equal sign, then you will either have 1 or 2 values for x that you plot. You will not have an interval. And the way you do that is you say this distance is either equal to 5x plus 3 units from 0 or the negative of that from 0. That means we draw two cases. 7x minus 1 equals 5x plus 3, and then 7x minus 1 equals the negative of whatever's in the absolute values. You need to be careful to put that in parentheses. So on the left we add 1, subtract 5x, and we get 2x equals 4, and then divide by 2. On the right, we have to distribute that negative sign, add 1, add 5x, and divide by 12, and then reduce. So our solution set is going to be 2 and -1, 6, and there won't be brackets or parentheses. Let's check our answer. If we use 2 for x, we have 7 times 2 is 14 minus 1. That's going to give us 13. And over here we're going to have 5 times 2 is 10 plus 3, and that's going to also give us 13, and the absolute values of 13 are 13, so that works. Now let's try -1, 6. On the left we get -7, which we'll put over 1 times -1, 6. I'm sorry, +7. All of that minus, and we're going to make that 1 6 over 6 because we are dealing with fractions. Over here we have 5 over 1 times -1 over 6 plus, instead of 3, we're going to make that 18 over 6. And when we simplify that, this here becomes -7, 6 minus 6, 6 is going to give us -13, 6. And the absolute value of that will be +13, 6. Let me clean that up a little bit. And over here we have -6 over 6, or -5, 6 plus 18, 6, and that's going to also give us 13, 6, and the absolute value of 13, 6 is again 13, 6. So you can see those check. If you put in any value for x other than those two things, then they will not be equal. Okay, again remember that absolute values are distances, and it must be either 0 or a positive number. This absolute value is equal to a negative number. That's not possible. There is no number that you can take the absolute value of and get a negative number. So that's an easy problem to solve. It's a special case, and the solution is the empty set. In number 7, we have an absolute value is less than a negative number, and again the absolute value is a distance. It is either 0 or a positive number, So if it's 0, it'll never be less than a negative number, and if it's a positive number, it'll never be less than a negative number. So again, you have the empty set. In this problem, we have that a distance is greater than a negative number. So a distance can either be 0 or a positive number. If the distance is 0, 0 is greater than a negative number. And if the distance is a positive number, that's always going to be greater than the negative number. So that means everything you plug in for x will make this inequality true. So all real solutions will work, and the way you graph that is to include negative infinity to infinity, and the way you write the interval is like this. So it's important you're visualizing distances, because when you're visualizing distances, it's obvious that a distance will always be larger than a negative number. Okay, now in this case we have that a distance is equal to 0, and we said that can happen. A distance is either equal to 0 or it's going to be a positive number. In this case it's equal to 0. So we only have one case, because we can't say 3x minus 12 equals negative 0. There's no such thing as negative 0. So we have 3x minus 12 equals 0, and we solve that, and we get 1 point on our number line, so it graphs like this, and we get one number in our brackets to show how we express the solution. And hopefully all of those problems gives you an example of how to visualize distances and how to visualize intervals on a graph, so that you can make sense of what kind of answer you're going to get even before you work the problem.